Welcome to 5.3 Inverse Functions. So before we get into the calculus portion, let's go through some pre-calculus review of inverses. Okay, so remember, in order to prove that two functions are inverses, we need to show that the composition in both ways, so f of g of x is x and g of f of x is x. Okay, our reflection property says that if we have f that's at the point a, b, and then f inverse is at the point BA. So we just flip-flop the x and y values. Does the inverse function exist? Well, we would use the horizontal line test on f. Okay, if f passes the horizontal line test, we know f inverse is a function. Okay, so how do we find the inverse? Remember, first we switch that f of x to y notation, y equals. We switch our x and y values. Then we solve for the y, and then of course we switch back to our proper notation, which is f inverse of x. Okay, so the derivative of an inverse. All right, so how do we find the derivative of an inverse? Well, we simply take 1 over f prime of that inverse. Or if we want to say that g is the inverse of f, then g prime is 1 over f prime of g of x. Okay, so helps to know that. All right. Okay, so then if we're looking at the graphs of these inverses, what we need to start looking at is slopes at certain points, okay, of the inverse or of the original function. So let's just suppose we plotted this graph, okay, and I just chose random points, all right? So if we have this function f, all right, and it passes through the point AB, and let's just suppose the slope of my tangent at point A is m, okay? Now remember, inverses are symmetric about the line y equals x, so that's why I threw that in there. So now if we were to graph f inverse, I would simply say it passes through the point B, comma A, okay? Now what we should notice is, now my slope of this inverse at that point is going to be 1 over m, okay? So the slope of the original at that point A is m, and so the slope of our inverse is going to be 1 over m at the corresponding point. All right, so one thing you can look at down low is our little side note, the slope of the tangent at A. F passes through the point AB. F prime of A is m, all right, that's the slope of our tangent line. So our inverse passes through the point BA, and the derivative of f inverse at B is going to be 1 over m, okay, because the x and y values switch. So let's look at this first example, and then we'll see how it goes. Okay, so the first example gives us the fact that f is equal to x minus 1 to the 5th plus 6. We want to find f inverse of x when x equals 7. Okay, so what that means is when I plug 7 into my inverse, I want to know what I get in return. So let's think about that in terms of the original f. That means, remember, we just switch x and y. I want to find the x value in f when f of x equals 7. Okay, so we could really say f of x equals 7 when x equals what? Okay, that's what we're looking for. Okay, so we kind of move over here now. So I'm going to set f equal to 7, and we're going to solve for x. So we subtract 6, we take the 5th root of both sides, we add 1, and we get x equals 2. So that tells us f of 2 equals 7. So then f inverse of 7, when x equals 7 for the inverse, is 2. So that's our answer. All right? Find f inverse of x when x equals 7. Our answer is 2. Example B says, find f inverse prime of x when x equals 7. So now we want the derivative of the inverse when x equals 7. So we're going to use the fact of what we found up above. We know that f of 2 equals 7. Okay, so we're going to use the derivative of f to help us find the derivative of f inverse, the slopes at those points. Okay, so the first thing we're going to do is we're going to look at the derivative of f, which is 5 times the quantity x minus 1 to the 4th. So we're using the x value when x equals 2 to find what the slope is at that point, 2, 7. Okay, so we plug 2 in for x, and we get the slope of our tangent of f at x equals 2 to be 5. All right, so the slope is 5 for f. What that tells us then is the slope of the tangent of f inverse at x equals 7 is just 1 over 5. Okay, so we're using the derivative of f, okay, at that point that we found, to then find the derivative of f prime by simply putting it as 1 over that slope. Okay, so now if we were to look at it graphically and kind of see what's going on, here's our function f, okay, and we have the point 2, 7 right here, and we're looking at our slope. Our slope is 5. So then on my inverse, we know that we have the point 7, 2. Okay, and our slope is now going to be 1 over 5 at that point. All right, we'll go through some examples in class as well, so don't worry. Here's just a more accurate graph of that problem that we were looking at, and we were kind of focusing on this portion right in here. Okay. All right, so now that leads us to our last example, okay, and we want to find dy dx at 0, 2 for x equals 2 ln of y squared minus 3. So we need to take the derivative, right? That's what we're trying to find, is the derivative. But when we take the derivative of the left side, we get dx. When we take the derivative of the right side, we have 2. Remember, the derivative of natural log is 1 over what's inside, so y squared minus 3. But don't forget about that chain rule aspect. And then we just have dy, because that's the derivative in terms of y. So if we clean this portion up, we are looking at dx is equal to 4y over y squared minus 3 dy. Well, if I divide both sides by dy, we then have dx dy equals 4y over y squared minus 3. But we don't want dx dy, we want dy dx. So all we're going to do is flip the numerator and the denominator. So we get dy over dx equals y squared minus 3 over 4y. And we're going to evaluate this at the point 0, 2, like it's asking for. Well, there's no x value to plug in for, so we'll just plug in for y. Okay? And when we do, and all is said and done, we get dy dx to be 1 over 8. Now, what we could have done is we could have done from the dx dy portion is we could have plugged in right away. And we could have plugged in for the point 0, 2 again. And we would get dx dy equals 8 over 1. So then what is dy dx equal? That's our 1 over 8. So this corresponds with kind of that same concept of those inverses and the slopes of inverses more so. Okay? All right, well, if you have any questions on this video, we will certainly address those in class next time we see each other.